Hey, it's Greg here. Let's take a look at review number 3. I'll give you some helpful hints. First of all, probability. One thing you'll need to do is total each column and each row. So for example, right here, this would be 99. This would be 99. And then get the total here and get the total here. And when you add all those up, that's going to be the grand total, which is 198. Okay, for a person to vote for Clinton, looks like that would be 99 out of 198. Then divide it, put the decimal, we're already done. What next on part B, with this little line right here, this means given that the person is female. So that means that it has to be narrowed down to just females. So how many were female? So that would be, this row right here is 94. So it's narrowed down to 94 people. Then out of these 94 females, how many voted for Trump? 42. So divide it, get the decimal, and you're done. And please use 3 decimal places. So this one would be the same. So given that you're only looking at Trump voters, so down here would be how many people voted for Trump, and then the Trump female voters would go on top. Slightly different than part C. The order does matter. So if 2 people are chosen, so to begin with, the first one would be 99 out of 198. And for the next one, since that one person has already been counted, there's no longer 99 people, there's 98. And then, guess what goes on the bottom right here? I don't want to do the whole thing for you. Let's see. So with this one, you first have to find out how many people there are. So that would be 93. So for the first person to be a male, it has to be out of the 93, there are 51 male. And now the next person, so that would be, there's 50 males left out of 92 people, and then the next one, and the next one, and then you do that for 12 fractions. This one would basically be the same, but the first 6 fractions have to look like the first 6 fractions of this one. The next 6 fractions is when you'd be using the women. 42 out of whatever, then 41 out of whatever, and multiply those. So with these type of counting questions, how many, you have to decide, does order matter or not? If the order matters, use permutations. If the order doesn't matter, use combinations. So without even reading the problem, as soon as I see this, then I say, oh, that means P equals 0.197, and then that's a binomial situation. So find the probability all 10 are Hispanic. So then you would take that decimal and raise it to the 10th. It's very similar to this problem right here, but with this one you have a number of people, so you use fractions and you count down. With this, when you choose one person to be Hispanic out of the whole United States and you say, okay, I've chosen that one person, then you're not going to change the percentage of people in the United States that are Hispanic. So you'll use the 0.197 times 0.197, etc. But instead of writing that down 10 times, I'd rather just say, take that decimal and raise it to the 10th. Find the probability at least 3 would be Hispanic. So the calculator does not have a function for bigger than or equal to. So what I need to do is do 1 minus the opposite of that. Oh, the other video's ready. And then the opposite of at least 3 is less than or equal to 2. And then you could use the binomial CDF. That's what would go right here. How many people would you expect? Well, if you just multiply the n of 10 with the decimal, you'll get a decimal answer. Since these are people, there cannot be a decimal of a person, so you need to round it appropriately. And then, as soon as I started to look at the next question, I see the word unusual, which tells me use the z-score. So the score of 5 minus the mean divided by the standard deviation. If it's over 2, that's unusual. License plates. So they need to start with a number or a digit. There's 10 digits. Then it's got 3 in a row that are letters. So hopefully you know how many letters there are in the alphabet. And then it's got 3 more that are digits, so that would be 10, 10, 10, and multiply those. Let's see. With this one, the word or means you add together. So for kings, there's 4 kings out of 52 cards. For hearts, there's 13 out of 52. And if I stopped right now, I have double counted the king of hearts, because I counted the king of hearts when I counted the kings, and I counted the king of hearts again when I counted the hearts. So then I have to say minus 1, which is the king of hearts that I double counted, and then find out that. So hopefully this helped. I'll talk to you soon.